Welcome back to our third unit, which covers most of Chapter 6 in our textbook. Well, we're in Section 6.6, the last section today. Our notes will pertain to these targets, so please write them down and everything comes after it. So after this lesson, you'll be able to solve cube root and square root radical equations, apply radical equations to real-life problems. That might be covered more in class tomorrow. And solve equations with rational exponents. I have these down and ready to show me for tomorrow. Okay, solving radical equations, three basic steps. Isolate the radical sign on one side of the equation. The radical sign, remember, that is the root sign. So whether it's square root or cube root, the root sign should be by itself. Okay, so everything away from that. And then whatever the root is, raise both sides of the equation to the same power as the root. If it's a square root, then you will square both sides. If it's a cube root, you will cube both sides. Fourth root, fourth power to both sides. And then you will solve the equation for x. Sounds pretty easy, doesn't it? Okay, let's try some examples. We look at this first example, the square root of x plus 25 equals 4. Notice, there is nothing in front of the square root sign. There's nothing behind the square root sign on this left side of the equation. So there's nothing to move away from the square root sign. All we're going to do then is we're going to square both sides. Because it's square root, we square both sides. The square root and the square cancel out. I get x plus 25 equals 16. I subtract 25 from both sides. I get x equals, what's 16? Minus 25, that's negative 9. Now to check it, you always want to check. You plug it back in. Negative 9 plus 25, does that equal 4? Well, negative 9 plus 25 is the square root of 16. The square root of 16 is 4. It checks. Okay? You can do that in your calculator as well. Let's try another one. And this one. The minus 9 is outside of the square root sign. Put this one down and out of our way here. The minus 9 is outside of the square root sign. We have to get rid of that first. So before we can undo, assuming this is cube root, sorry, before we can undo the cube root, we have to get rid of anything that's multiplied, added, subtracted, or divided outside of the square root, or cube root in this case. So we add 9 to both sides, we get the cube root of x equals 8. Now we can cancel out that cube root part, which is cubing. 8 to the third power is 512. Okay? Plug that back in. The equation to check. The cube root of 512 minus 9, does it equal 1? Cube root of 512, well, the cube root of 512 is what? What is the cube root of 512? Our calculator, we do seconds. Let's get out of here. Second, math. Oops. Not second math. Cube root is 4. And we put in 512. Let's see what we get. We get 8. 8 minus 9 is negative. Is negative 1. It checks. Okay? Should have been substituted, but I want to make sure in case she pulls up at home or on your test and you realize we just did what the cube root of 512 here, 8 cubed. You can check it on your calculator. Down here, this last one, we'll skip this one, but what will we do to start this equation? Just to try to get it started, and you can finish this one on your own. You would have to divide both sides by 2, because 2 is multiplying the cube root of x minus 3. And then we can cube both sides and go on. So I'll leave that one for you guys to try. So we addressed our first target of radical equations. What about equations that have rational exponents? We're still going to treat them very similar to the radical equations. Okay? So in that sense, we have to get the variable raised to the power isolated. Kind of like PEMDAS, following orders of operations. So we're going to divide both sides by 3 in this first example, and we're going to get x to the 3/2 power equals 375 divided by 3, which is 125. Now what do we do? Well, there's two ways we can look at this. We can rewrite this as a radical expression, right? This would be the square root of x cubed. So one way we could do is we could rewrite that as the square root of x cubed equals 125 and proceed that way. So if this is the method 1. So if we do that, we would cube or square both sides. When we square both sides, what is 125 squared? 25 times 125. 125 squared is 15,625. So, let's go there. 15,625 equals x cubed. Now we cube root both sides. We cube root both sides. It's the cube root of 15,625. Go back to our calculator and go down to number 4. 15,625. Get 25. So that's one method. That's one way to do it. Obviously, check these. Plug it back in. 25 to the 3/2 power in our calculator. We'll do that in a minute. Okay? Let's look at method 2, the other way we could do this. The other way we can do this is we can say, okay, we have the equation x to the 3/2 power equals 125. Well, we can raise both sides of this equation by the same power. And if I raise both sides of this equation to the power of 2/3, what will that do to the left side? Well, this would be power of a power. So we'd have 2 times 3 over 3 times 2, which is 6 over 6, or 1, which means they cancel out. So we get x equals 125 to the 2/3 power. And when we put that in our calculator, can we put that in our calculator? Yes, we can. 2 divided by 3, we get 25, same answer. Okay? Now to check it, plug it back into the original equation. This is our check now. 3 times 25 to the 3/2 is 375. That's what everyone wanted for our original equation. Okay, so it does check by plugging it back in. Okay? So if we get, okay, solving an equation with an extraneous solution. Solving an equation with an extraneous solution, what we do for that is, what happens is when we have to come up with a quadratic equation when we square both sides. So sometimes there'll be solutions when we square both sides, we get a quadratic equation, as we're going to see here in a minute, and when you recheck the answers, they don't work. So sometimes in a solution that appears to be a solution really doesn't work. That's what we call an extraneous solution. So for the square root of x minus 6 equals x minus 8, I'm going to undo this by squaring both sides. And now we can see that this makes it a little more complicated. Because on this side, I get x minus 8 squared, which really is x minus 8 times x minus 8. So this is where we may FOIL it off to the side, or we may use a table. I think a lot of us like the table method, so I'm going to go with that. We get x squared minus 8x minus 8x plus 64. X squared minus 8x minus 8x plus 64. We end up with x squared minus 16x plus 64. So we'll work on the side here, and we're going to substitute that for the x minus 8 times x minus 8 into our equation. Remember, the rule for solving quadratics is you got to get all of your variables on one side and numbers on one side. So we're going to add 6 to both sides. We're going to subtract x. We end up with 0 equals x squared minus 17x plus 7. So at this point, we just think back to our Unit 1, Chapter 4, Methods. We can factor, we can graph it, use the quadratic formula, but we have to find the zeros. So can we factor it? Let's look. Well, if we can factor, we're looking at bottoms up, right? A times C, 1 times 70, which is 70. What adds to make B, which is negative 17? So you can take a minute trying to figure out what the factors are that will combine for that. But if you look at it, we have a negative middle term and a positive last term. So that means both terms have to be negative. Negative 10 times negative 7 is negative 70. And negative 10 plus negative 7 is negative 17. It works for both. So 0 equals x minus 10, x minus 10, times x minus 7. Bottoms up says divide by a. A is 1, so we realize that's not going to change any of our answers. So now we take x minus 10 equal to 0, x minus 7 equal to 0, solve each equation. We end up with x equals 10 and x equals 7. So now we have to check and see, are either of these solutions extraneous? Are there any solutions that won't work? Well, we have to plug them back into the original equation. So let's plug 10 into our original equation. We get the square root of 10 minus 6. This is our checking work. 10 minus 6, does it equal 10 minus 8? 10 minus 6 is 4. Square root of 4, 10 minus 8 is 2. The square root of 4 is 2. 2 equals 2. We always assume the positive square root when we're simplifying aside. Okay, we're not solving an equation, we're simplifying. So it's always the positive square root. It checks there. How about 7? Square root of 7 minus 6. Does it equal 7 minus 8? 7 minus 6 is 1. 7 minus 8 is negative 1. The square root of 1 is 1. 1 does not equal negative 1. Therefore, 7 is extraneous. It appeared to be a solution, but when we plug it back in, it does not work in the equation. That's just an extraneous solution. Okay, let's try an example that looks like this. What if they're both rooted, the same root, in this case both square roots? Well, there's nothing to move around. We're just going to square both sides. What happens here is we get a linear equation. We get 2x plus 5 equals x plus 7. So we're going to get the x's on one side in a linear equation, the numbers on the other. I chose to move the 5 to the right. So that means I'm going to move my x to the left. I do that because I always like to have my x terms on the left-hand side. And I get x equals 2. Let's check and see if it's extraneous or not. Maybe there's no solution. That can happen if none of your answers work, and it's a no solution problem. The square root of 2 times 2 plus 5 does it equal the square root of 2 plus 7. 2 times 2 is 4 plus 5. 2 plus 7 is 9. You get the square root of 9 equals the square root of 9. I think that works. You can go a step further and say it's 3 equals 3. But we got the same thing on both sides. Okay, let's review our targets for today. I think we can look back and say we addressed all of these except maybe one, but the other we'll address that in class. We're going to solve cube root and square root radical equations. I think we did that. We were going to apply radical equations to real-life problems. We'll do that tomorrow in class. And we're going to solve equations with rational exponents. We did that as well. Okay? So remember to always check your answers, especially when you're squaring both sides and you end up with quadratics to solve. You can get extraneous solutions. Have your notes with you tomorrow. We'll check them in class. Have a great day.